function overloading in C++. Before we go into the syntax or the different things involved in this concept, let's try to understand. Generally, we write main, and in main, I write some statements, then I will define a function fun with arguments a comma b. I am calling a function like this, right? And I am doing some set on steps, and then here I will be having some return type of that function, then function int x comma int y. Inside it I might be doing some steps like this I can write. So this is function call. So it will, the control will shift here, it will execute this set of statements and come back to this part again. This already we know how this generally functions happen in programming, whether it is C or C++, right? Now I will, this is the general case. I will take a typical example. Suppose I want to write a program to add two integers. Also, same, I want to write another program to add two floating point numbers. And third one, I want to write a program to add one int plus one float numbers I want to write. And I want to implement these three, okay, in a single program. These three I want to implement them in a single program as functions. So what will you do generally? In the main function, you will be declaring variables accordingly. You need two integers, two floats. So maybe I will give here int a equal to 10, comma b equal to 20. I gave integers. You may write here float, what we say, x equal to 5.5, comma y equal to 6.5. Okay, I declare variables like this. Then I will call a function add ii. I will be passing a comma b. I will write another function add if. I will be passing a and x. I will write another function add ff. I will be passing x comma y. If you observe this scenario here, we understand that we are trying to define three functions. One function to add two integers, another function to add two floating point numbers, another function to add one integer and one floating point number. Okay, because why am I writing three functions separately here? Why to write three different? Because when you write a function, we have something like return type, then function name, and then arguments. General syntax of functions. So return type, here it is int, here it is add. We have to write int comma int. We generally define like this. Above main, we write some statement like this as global declaration, that the return type of the function is integer and the arguments which I am passing are int and int. Okay, that's the reason we have to define it like this. Now you have to define another function, int add f, where I'll be writing float comma float. Okay, int comma int add float comma float, right? So I have to write functions like this, int add if, where I'll write int comma float. So three different functions we are defining. So what is happening? The length of the program is increasing. But how do we differentiate? Okay, this is add, this is add if, this is add if. Like this, I have so many add functions. Name of the functions are beginning with add. Okay, but I am unable to differentiate which function is used for which process. It is unclear for me, right? Though I am adding two different numbers, but still we are confused which function is used for which. Okay, like this add is there, you assume add and subtract is there, sub a, then sub b, then sub cc, all similar. Suddenly in that very big program of 1000-10,000 lines of code, it is very difficult for you to identify this sub b means which function, I don't know. This sub a means which function, I don't know, right? Because you may be confused when you have multiple functions there which looks like same name. This all conveys, these three convey that we are going to add. we are going to add, but there is confusion again among them. Which one is used for what purpose? That is not clear. To avoid that, we use there is one concept or one important building blocks of object oriented programming. One among them is polymorphism. Okay, one feature of C++ is polymorphism or object oriented programming. What does this polymorphism means? Same name, but different meaning, Okay, polymorphism, different forms, same name but different forms. Okay, right. So we try to, function overloading is a proof, it's an implementation of the concept of polymorphism feature of object oriented programming. Function overloading is an implementation of the polymorphism feature of object oriented programming. Okay, right. Let's try to understand about function overloading. What are the different rules in function overloading? How we can write programs using this function overloading. So again, this little what we have seen, function overloading is an important feature of object oriented programming where two or more functions can have same name but different parameters. In C programming, you cannot have like this, add int x comma int y as one function, again another function add int x comma float y. This is not allowed because same function name is repeated 2 times. That is not allowed in C programming. Okay, this is not allowed in C programming, but in C++ you can have two or more functions can have same name but different parameters. Okay, how can I give different parameters? I can give different parameters like this. I can give int add int comma int. This is one function. Same function I can use int add float comma int. Float comma int. This way you can give multiple same function name but different parameters. Okay, another case is like this. You can give int add function. You can give parameters int comma int, and you can write the logic for that. In the same program, you can have function like this, int add int comma int comma int. You can write the logic. See, same function name, but the number of type of parameter, though it is same int, but the number of parameters is different. So in function overloading concept, we can have different parameters of same data type or different number of parameters. Okay, different parameters of same data type or variables with different data types. Okay, right. So this function overloading is considered as an example of polymorphism feature in C++. Polymorphism means same name but different forms, different meaning for that. Okay, that way you can implement this function overloading in C++. What are the three conditions? What are different conditions where can we apply function overloading? Okay, see, the first condition here is that parameters should have a different type. Like this, you can give same function name add, but you see here it is int, here it is double. So parameter should be of different type. If you want to give same number of parameters, what is number of parameters here? It is 2, but the data type of those variables is different, int here and double here. That is first condition. Second condition, parameters should have a different number. Though they have same data type, the number of arguments should be different. Number of parameters should be different, like this, int AB, int ABC. Then you can write same program name like this. It is allowed in C++. Third one, parameters should have a different sequence of parameters, like this, int A double B, double A int B. Here also we can implement the this feature of polymorphism or function overloading. Okay, so these three are the very important conditions here. First one, they should have different data types. Second one, they can have same data type but different number of arguments. And third one, they can have a different sequence of parameters like int double or double int. This way you can implement function overloading in C++. Data types of same function be same or different. Okay, different. Now I have one question for you. I write a function int add int a comma int b in a program. I write some statements and close this. Then here I am writing float add int a comma int b. I have statements. You see the name of the function is same. When we say when the name of the function is same, then the parameters should differ either in the data type or in the count of variables, count of arguments, or the sequence. But you see here I gave int a, int b, here also I am giving int a, int b. But the return type is different, int and float. Can we call this concept as polymorphism or function overloading or not is my question. This example where we have, okay, this example where we have same function name, same arguments, but different return type. Okay, can we call this as function overloading? Just guess, just think of it. Return type is different. Return type is different, but the name of the function, the arguments are same. Please tell me, can we call this as function overloading? You got my question? I am writing two functions in a single program. Okay, right? Add int ab as parameters. Right? Let's see this. See, what is my rule saying that? Rule says parameter should have different type. Here it is same type. First condition itself failed. Parameter should have, we are nowhere talking about return type. Function overloading is least worried about the return type of the functions. Definitely the functions should differ only in terms of arguments and their data type. Return type has nothing to do with function overloading. Though the return type is same or different, only this is different. If this is different, then we say it is function overloading. Got my point? I hope you all understood. Function overloading, we have three conditions. They should differ in the data type of the variables, or they should differ in the number of arguments if they belong to same data type. Third one, they should differ in a sequence. They should have a different sequence. Int float means next I can have float int float. That way it should differ. Only then we claim that we implement function overloading. Okay, if the function, both function name same and also same data type, then who will execute first? Some question is like this. I have add int and int. Again I have add, I have int and int. This is not at all allowed. This is an error, because it is not function overloading. It will say same function doing same task. Ambiguity error. I do not know which one to choose here. It will throw error. That's why we are saying you can, the only advantage what we get here is you can have a same function name. The advantage here is you can have same function name. Add like this. You may change something here. Not a problem. Okay. One more question I have here. Int add int a comma float b. I have some set of statements. Then I have float add float a float b comma int a, for example. Okay, can we call this as example of function overloading? What about this one? Can we call this as example of function overloading? Int add int a float b, float add float b int a. Can we call this as function overloading? Yes, because see, the order is different. The order is different. This is different does not have any impact. It does not, we are least bothered about the return type. Okay, function overloading. Let's see some examples to understand function overloading. We will see this. See, in main, I am having a function add, I am passing 10 and 2. Same function add, I am passing 5.3, 6.2. So when I am passing 10 and 2, it comes here, it will do addition. When I am passing 5.3, 6.2, it will come here, it will do addition. This way. The advantage here is that, see, this is a simple example. Let me try to explain you why are we using function overloading. What is the use of this function overloading? Maybe you are working on a large project which has 10k lines and you do lot of operations. In that you do lot of operations. Okay, so maybe it's an ATM example. If it's an ATM example, you have functionalities like withdraw, deposit, pin change, right? Balance inquiry. Like this, you have phone number update, cardless deposit. Like this, you have multiple features in ATM. I am trying to implement a right program for all these things. In withdrawal, I have again multiple things. In withdraw, I have multiple things. One is using ATM machine or ATM card. Other using directly going to bank. Other using YONO. YONO, if you are using SBI, I'm just giving an example of SBI. YONO app. You have some apps, banking apps. So like this, you can have multiple things, right? So you have one very big project. It has lot of functionality. Under each category, there are different types. It is very difficult for us to give naming convention, and it's always confusing which function is for what purpose. Okay, so for that, all withdraw option, you can write function name as withdraw only. Parameters may differ. If it is ATM, different thing. If it is some app, it is different thing. If it is through bank, it is different thing. That way you can implement this function overloading concept, right? So this is one very simple example. See, in main, I am passing 10, add 10 and 2, I am calling this. Accordingly, this function will be called. For this function will be called. Let's see second example. Second implementation. See, same function add, both are integers, but the number of arguments is different. Here it is 2 arguments, here it is 3 arguments. See, I have 10 and 2 here, and here I am having 5, 6 and 4. So when 2 are being passed, it will call this. When 3 are being passed, it will call this. This way also they can differ. See, same thing, void add, only the number of arguments is different in the both the examples, both the functions. Third one, you see 10 2.5 and 5.56. So I am passing int and double and int. Simple just example to implement function overloading. Why? Because polymorphism, important point, polymorphism, same function, different forms or different jobs. Same function name but different jobs based on the number of parameters. This is not allowed in C programming. This is allowed in C++ exclusively. We have this here. Okay, 3 simple examples. Now, there can be some cases that cannot be overloaded in C++. We cannot overload all the functions always, right? See this example. This is what I was talking about. Function declarations that differ only in return type. Okay, see, I am having 2 functions, FOO. I am having another function, FOO. The return type of this is int. The return type of this is char. See, same function, arguments same, but return type is different. No, this cannot be function overloading. This will throw error. This will throw error, ambiguity error, because function name is same, but this is different. This is not allowed. Okay, right? Functions that cannot be overloaded in C++. If 2 functions, maybe you can say, same example again, I am repeating. It is taking one variable int a. Another one, same character FOO, it is taking same variable int b. So data type is int, function name is same, not allowed. This is not considered as function overloading. So this is one case. If the functions differ in the return type, they cannot be considered as function overloading. Second one, try to understand this second one, right? We little go into class concept here. Member functions. What is member function? Any function which is defined inside the class name. any function which is defined inside the data variable or member variable or member functions, we call like that. Okay, so member function declaration with same name and same parameter type list cannot be overloaded if any one of them is static. If any one of them is static. See here, class test, I am having class, a class is there. In that I am writing static void function int I. There is another function void function int I. See, you may think these three are same, right? Int I, void, right? This is also not considered as function overloading, because if one is static, other is not, it is not function overloading. Okay, static, if at all there is a static, we cannot consider it as function overloading, right? I hope you got my second point. Third one, observe this. This is very important because you might already know, you might have studied about pointers concept in C programming, right? So if you see, I am to a function, I am passing a pointer int star ptr. When can we write like this? We can write like this when from the main function I am sending address. I am sending the address. Whenever you are sending address, you can receive it like this, int star ptr, address of an array. For example, if you are sending, you can write it like this and receive it. This is one way of passing address of an array to a function. This is fine. You see the second one, int fun, it is declared int ptr as empty brackets. This is also allowed when you are sending address of an array. This is also allowed. You can either write this format, first format, or second format. Indirectly, it means both these notations are same. The meaning of both these syntaxes is same, so they cannot be overloaded, because pointer with star and array with this are equivalent. Okay, pointer with star and array with brackets are equivalent, right? That's why we cannot overload, we cannot assume that this is overloading. They are actually same meaning, because for both of them the input is the address of the array. The input is address of the array, right? Yeah. So here I talked about static function. We are yet to study that. We are yet to study about friend function. Friend. We have so many things. Friend, static. Okay. This, like this, we have so many types. We are yet to study those things. I will explain you what is that. But since we are seeing about function overloading, in that one point is static cannot be considered as function overloading. I will talk about each of these. This unit is all about functions. Okay, right. So this is also over. Now, two parameter declarations that differ only in default arguments. I already taught you what is default arguments. It is also same thing, right? You can have same function add. You can have int x, int y, and int z equal to 0. Like this, you can give three parameters. So you can call this function add with either 10, 20, or you can call this function with 10, 20, 30 default arguments, right? I think we discussed this already. Add int x, int y, z equal to 0, add 10, 20, then x will 10 will go into x, 20 will go into y. It will add x plus y plus z, that is 0, it will be added here. When you give 10, 20, 30, this 0 is replaced with 30 here. So it will add 10 plus 20 plus 30. Okay, so we have seen about default arguments. Now see here, I have one function int f, int xy normally. Here I have same function int x and y equal to 10 I have given. I am taking advantage of the default argument concept. This is also not considered as function overloading, because, right? Because if you observe here, function name is same, data types are also same. That's why it is not function overloading. Though it seems like he has used the concept of default arguments here by writing like this, but still this cannot be considered, because int f, the function names are int comma int. Here also same thing, second function int f, the function names are int comma int, like this. So we don't need this cannot be considered as function overloading. Next, one very important point about function overloading with float variables. Function overloading with float variables. Let's see this example. You just focus here. Void test. I have one function void test. Okay, void test. See, float and float. Similarly, I have void test int and int. Okay, void test float float int int. Right? From main, I am calling test function and I am sending both as floating point numbers. Both as floating point numbers. Right? If you observe this. So this is function overloading. Yes or no? This implementation is function overloading. Can you tell me yes or no? This is function overloading implementation, because though function name is same, they differ in the data type. That is true. Can we call this as function overloading or not? Can we call this as function overloading or not? What are our three conditions of function overloading? Condition 1, they can differ in data type. Condition 2, same data type but different number of arguments. Third one, different sequence of arguments. Okay, so if you see here, test, same name, but the data types are different. So therefore it is true. This is function overloading. This part is function overloading. Why? Because condition, you focus on the condition. What are our three conditions? Right? They are differing in data types. But now there is one challenge with this. What is that? When I call a function with test 3.5, 3.5, by default in C++, floating numbers are converted to double. Floating numbers are implicitly converted to double format and the operation is performed. Okay, when you are when you are passing values as floating point numbers, they are implicitly converted into double data type and then they are passed here. So these two 3.5, 5.6 will be converted to data type double and they will call here. Now when I am saying they are converted to double, it means these two are double values. It is like double x comma double y. Now, do you have a function test which is taking two double variables? Here, do we have? No, because one is taking float, other is taking int. Okay, again I repeat the point. When you are passing values in C++ like this 3.5, 5.6, assuming they are float, if you assume that they are float, compiler will treat all floating point numbers as double, or it will convert them to double. Now these two variables are double variables, double data type variables, and in the function call, I have a function which is taking float, I have a function which is taking int. I do not have a function test which is accepting double values like this. I do not have such kind of a function which is accepting double and double. Okay, so this will throw error. It will say that function, no, it will throw error that we are calling double and there is no matching function available here. That's why you should be very careful while dealing with the floating point numbers in C++. Okay, but how do we rectify this? This is the reasons. Okay, right? It is, what is the fact here? Okay, when there are same function name, they are like ambiguity. If you see, floating point literals are treated as double unless explicitly specified by a suffix. As per C++ standard, all the floating point numbers are treated as double in C++. So since compiler could not find a function with double argument, it got confused and it threw error. Okay, it got confused. The value should be converted to double, to int or float. It does not know. I hope you understood the problem here. The floating point literals are in the form of they will be considered as double in C++. So for that, what we can do is you have to write, you have to specify, right? You have to explicitly specify by a suffix. What is that suffix here? F. You have to write test 3.5f comma 3.6f like this. Now this is considered as a floating point number. So in this case, this above function is called float. Float is called, and function with float will be given as output. I hope it is clear that in C++, always if you want to play with floating, add f to that. Otherwise, by default it is double. By default it is double. There is one beautiful question. If I just go a little sidetrack, if you give permission, I'll just go into a small coding question. There is one question like this. The question is like this: if me is equal to you, okay, printf or cout for your comfortability, I'll write here like this: cout oh, this is not required. If you are giving endl only, we need this. Else cout okay. This is now what are those me values? It is declared float me equal to 5.25, double u equal to 5.25. Can you guess the answer? I hope the question is clear. Float me equal to 5.25, double u equal to 5.25. Both are same numbers, 5.25, 5.25. If me is equal to you, then you, then else I hate you. Okay, ILU or I hate you. I have two things. Can you guess the answer? This is a previous company question. Can you guess the answer? If part, okay, if part or else part. Is it if part or the else part? Which one will execute? If part or else part. This is as it is. This question is a previous question. Right? So yeah, I understand. I get different answers from you. For this numbers you are telling, if is some of you are telling if. Same problem, same question. I have float me equal to 5.34, double u equal to 5.34. Will there be any change in your answer? Will this give me if part or else part? Will it give me if part or else part for the second values 5.34, 5.34? You got my point. Same thing I'm asking one more time. When float me equal to 5.25, double u equal to 5.25, you are telling if part will execute because both are same. I have changed the numbers now. Float me equal to 5.34, double u equal to 5.34. In this case, what will happen? Will it still give me if part? Will it still give me if part? Why 5.25, 5.25, 5.34? What is the difference? Right? So for this, let me clarify you. You will be surprised to see the answers. For this 5.25, 5.25, answer is this if part. Whereas for this 5.34, answer is this else part. So I want to summarize this, what we have seen here. Floating point numbers are always dangerous. You should be very careful. Okay, we will see that in due course, sometime when we get time, or during the break hour, we will try to see the answer for that, how it is. It's a lengthy explanation. I'll just give an idea to you. You may just study or understand why it is so that way. But when it is 5.25 and 5.25, it gives if part. When it is 5.17, 5.17 or 5.73, 5.73 or 5.01, 5.01, always it will give you else part. Okay, so we will see, we will discuss that once we complete this function overloading concept. I hope this is clear. You have to attach here F. Next, can main be overloaded? Very important question, very popularly asked question. Can main be overloaded? Because main is also a function. Can I overload it like this? Int main, int main, int main. See, it is int, it is character. Here the number of arguments is same, but data type is different. Here the number of arguments is different. Can we write like this? Is it valid? Is it called as function overloading or not? Is my question. Is it a valid function overloading or not? Valid or not? Can we overload main function? Can we overload main function? Okay, see, the very important and the common programming point we all studied multiple times is that execution of a C or a C++ or a Java program or any language program, it begins from where? Where does the execution of a program begins from? Generally, not this example, any example you take. You write a very lengthy program using classes, functions, structures, unions, combined program. Where will the compiler start its execution? Where will the compiler starts its execution? Hello? See here, yeah, this is what our friend has said. It is true. Execution begins from main. Execution of any program begins from main. Any program you see here or the previous examples which you see, it will not execute these things. It may syntactically check this, but execution will begin from main only. From main, then test, then it will go to that function, come back here again. Execution always begins from main. So when I have 4 main functions, compiler is confused from where should I begin, which one is my actual main, where should I start execution of the program. I am not aware of it. Confusion, it does not know from where to start because there are multiple mains. Syntax is same, and we know you might have studied about command line arguments, CLA, in C programming. You can use some arguments to main. So this looks same, this also looks valid, this also looks valid, this also looks valid. Where do I begin? I do not know. Compiler is confused. Okay, so this is a drawback. We cannot consider this as a overloading. We cannot overload main function. This way you cannot do. There are other ways of doing, but this way of writing program, you cannot implement the concept of function overloading. I hope you understood the reason. This way you cannot do because int main, int main, int main, int main. Where should I start? Which is the actual first one? How do you differentiate it? That's a confusion and a problem for compiler. This will throw error. Okay. Now to overload main function in C++, it is necessary to use class and declare the main as a member function. Only that way you can overload them, but not this style. Okay. So what you can do, you can necessary to use class concept and declare the main as a member function. In a class you define the function main, and that main you can call using creating objects. Okay, and the very important point, main is not a reserved word in programming language. So you can write something like this: main can be a variable. Main can be a variable. Main plus plus you can write like this. Main is not a keyword. If it is not a keyword, we can use it as a variable. We can use it as a variable. Okay, so this is okay. This is valid. Int main equal to 10 and cout main. So it will give 10 as the answer. This is valid. I can declare main as a variable name. But if I want to overload like this, I cannot do. The one way of doing it, create a class, in that define a function main. Using an object for that class, you can invoke that function. I will show you the implementation of that. Okay, let us see the example. See, this is okay now. This is fine. Now, what is the difference between that program and this program? Here, it will come and say it's a class, this open bracket and close bracket. So, it will simply jump to this main. There is only one main. From here, it will start executing the program. It will create an object for this test. Then you can call the main function which is there inside with the different variables and different data types. Now, compiler can directly come to this function. It can start executing from this first line. Why? Because there is no other main function. There is no confusion like this case. Here in this case, there is lot of confusion. This is also valid, this is also valid, this is also valid. But this we removed it by putting those inside a class. Now this have become the member functions. So obviously compiler will jump to this first line. It will create an object. It will call these three functions. Three means integer, this will be executed. String means this will be executed. Two variables means this will be executed. You will get the answer. Normal. So if someone asks you, can main be overloaded, or someone forces you that somehow overload main, apply function overloading for main, then the only option is creating a class, defining those functions as like this, public functions, and then accessing them using the object of class. This way we can overload function in C++, right? I hope it is clear. Let's see the last concept in function overloading. I think I remember somebody asking me what is difference between function overloading and function overriding, okay, and overloading. What is the difference? Overloading you understood now. Overloading you understood, it achieves during compile time. When you are executing the program, we already know that multiple definitions of function by changing signature, that is changing number of parameters, changing data type of parameters, and return type does not play any role. This already we have seen about function overloading. What is function overriding? What is function overriding? For this, I have to explain you little about inheritance. Okay, I have to explain little about inheritance. Again, this we have it as a separate unit, but little information I would like to give about inheritance here. We already discussed about little about this, that you can inherit the properties of the parent class to the child class. So I have class parent. In this I have some variables, then I have a function. I have a function void abc. I have a function in parent class. Okay, then I have another child class, child. Okay, class child, which is derived from parent, We will see how to implement inheritance, but just for an understanding now. In this also I have a function void abc. Okay, now if previously we studied that if I create an object for parent, class like this, parent object 1, if I create, with this object 1 you can access this function abc. You can call this function abc. Since this child is also derived from parent class, the object of child class, that is child O2 object, O2 can also access this parent class function we studied before. Right? You are trying to create an object 2 for child class. When you are implementing concept of inheritance, child class object has privilege to use all the variables and functions of parent class. That way this abc can be used. But what I am trying to do here, see, I am trying to create the child class. In that also I am putting same function name abc. So parent also has abc, child also has abc. Now when I called o2.abc, obviously it will go to child class only but not parent class. Okay, it will go to child class only but not to parent class. Right? This is called function overriding. See the example here. Class A public, I have a display function. Virtual void display function is there. Class B colon public A. This is actually inheritance. This is inheritance. We will see about that. Again, I have void display. Now, if I create an object for class B, if I write B1, object of class B is B1. If I write B1 dot display, it will obviously call the child class 1. Answer will be by. Okay, right? If I what is the use of inheritance? Inheritance says don't declare this like this, not required. Already parent class is there, use the same function. If I don't write this, if I write B1 dot display, though class B does not have this function display, it will inherit from the parent class. It will inherit from the parent class. But here I am trying to override the definition of hello with by. Okay, this is function overriding. It is the redefinition of a base class function in its derived class, with same signature, means same return type, same parameters. See, same return type and same parameters. This can be done only in derived class. This can be done only in derived class. Okay, this is about function overriding and overloading. Right. See here, just an example of that overloading and overriding. I'll go to main. See, there is a class base class. It has a function void display and show. There is a class derived class. It has a function display. So when I create an object dr for derived class, and if I write dr dot show, this is I can access because there is no show function in derived class. But I am able to execute this. Why? Because it is inherited here. Inherited. Okay, this is fine. See, okay, sorry. See here, I am writing here base class. I am trying to create base class object. I am trying to create base class object. Okay, BS, and I am assigning with dr. When I write BS dot display, it will execute this one, not this one, because using the child derived class object, if I am calling display function, it will refer to its local function, that is its own function. It will not look for the parent class. He himself has one function display. Okay, this is called function overriding. Though there exists a function display, you are trying to override that in your child class. Okay, this is about function overloading and function overriding in C++. There are some differences about overloading and overriding. Overloading is simple, provides multiple definitions of function by changing signature. Overriding, you can have same signature, but only thing, one can be defined in parent class, other should be defined in child class. This is compile time, this is runtime polymorphism. Okay, compile time polymorphism, because during compilation of the program, I will verify that overloading. But the function overriding happens only once you create object, no? See, only once you create object, we are able to call these functions. So that is, and when is the object created? During runtime, but not compile time. During runtime, object, it is created here. It is created here. Object is created in this main, but it is actually given life only during runtime. That's why we say that function overriding is a runtime polymorphism concept. Function signature should be different. Here it can be same. Overloaded functions are in same scope. They are in different scopes. Okay, we will talk about the scope concept. Similarly, we have some definitions and some differences between overloading and overriding. Okay, right? Because in overriding, we talk about inheritance concept, but here it does not need any inherited concept. Okay, right? So these are few differences between function overloading and overriding. If you quickly summarize what we have seen, we have studied about function overloading in C++. What are the rules? 3 different rules. They should differ in different data type. They should differ in the number of arguments, or they should differ in the sequence of parameters. If they are differing in these 3 forms, we say we implement function overloading, and we have seen some examples. Then we also seen which functions cannot be overloaded. In that, functions with having same return type, different return type cannot be overloaded. Functions with static and without static cannot be overloaded. Array and pointer representation of arrays cannot be overloaded, and default argument implementation also cannot be overloaded. Like this, we have seen different concepts in function overloading, right? Function overriding is one very important concept. We will go through that in much detail.